Very good morning. Let me discuss the another session of the estimator, that is nothing but the linear model. Okay. So till now we have discussed in the last session we have been discussing something regarding the some of the examples of extension of CRLB to the vector parameter. Two examples we have discussed, and the last one is something regarding the line fitting. Line fitting is not, yes, line fitting, and these examples can be represented in the linear model also. Okay, so why to go for the linear model? That is one question. So already you know the determination of MVU estimator in general is one of the difficult tasks. Okay, so because in order to determine the minimum variance unbiased estimator is somewhat a difficult task. So if a large number of signal processing estimation problem can be represented by a data model, what I am telling is the large number of uh, signal processing estimation problem can be represented by using a data model that allows us to easily determine the estimation, and that model is nothing but your linear model. Okay, so if you have a large number of signal processing estimation problem, so that can be represented by using a data model, and that data model is nothing but the linear models. Okay, um, we have to see what is linear model, definition of linear model, how we can how we can find the estimation by using the linear models. Two example we can represent it. Or anyway, already you have seen something in the line fitting. The same example we can continue here also in order to describe the usual the procedure for the linear models also. Okay, so we can continue with this one, linear model, the definition of the linear model. Okay, so many estimation problem can be, as I told you, the large number of estimation problem can be represented by using a data model, and that data model is nothing but the your linear model. Okay, many estimation problem can be represented by a linear model that allow us to determine the estimator easily. So represented by a linear model, many estimation problem can be represented by a linear model that allow us to determine the estimator easily. Okay, so as in case of, we can define the linear model, general expression of the linear model by just refer the previous example, that is the line fitting example what I have discussed in the previous video lecture. Just recall that one, and the same observation we are taking here also for the definition of for defining the linear model. Okay, definition for the linear model, I will just take the observation of a line fitting, just like x of n is nothing but a plus bn plus w of n, where w of n is nothing but a white Gaussian noise with n equal to 0, 1, 2, etc. n minus 1. For the linear model, x of n, you can write x of n is nothing but a plus bn plus wn, where n is 0, 1, 2, etc. n minus 1, and w of n is a white Gaussian noise. You know the slope b and the intercept a are the parameter that has to be estimated. Okay, just like this is the same thing what we are discussing in the line fitting also. The same observation I have taken here for defining the linear model. Okay, that is x of n is nothing but a plus bn. Then you will ask one question: why is it possible to utilize this linear model for finding the estimation problem? Yes, it is possible. Even if you are going for the line fitting, you can utilize this linear model for finding the unknown parameter a and b by using the linear model also. Okay, but if they are specifically asking you have to find the estimation using the linear model, then go for only by using this method. Otherwise, whichever method you are saying, it is simple. If they are not representing the particular model or particular method for finding estimation, you can adopt any method that is suitable for you. Okay. uh, Slope here, as I told you, a is nothing but the intercept and the b is nothing but the slope. That has to be, that is a two parameter that has to be estimated. Okay, so I can represent this in the form of x of n is nothing but x of 0. I can take it as a plus b of 0 plus w of 0. That is one case. X of 1, a plus b into 1 plus w into 1. X of 2, a plus b into 2 plus w into 2, etc, etc. X of n minus 1, I can write it as a plus b of n minus 1 plus w of n minus 1. So I will just representing that like this. That is x of 0. I can write x of 0 as a plus b of 0 plus w of 0. X of 1 as a plus b of 1, b into 1 plus w into 1. X of 2, a plus b into 2 plus w into 2, etc, etc. I can write x of n minus 1 equal to a plus n minus a plus b into n minus 1 plus w into n minus 1. So I can represent this equation in the form of x is equal to h theta plus w. X is nothing but x of 0, x of 1, x of 2, and that is nothing but n cross 1 matrix, and h is nothing but, I can represent h as 1, that is the constant term, that is a and b. A is nothing but intercept and b is nothing but the slope. 1 0 1 1 1 2, etc, etc, 1 n minus 1. That I will represent in the form of h, and the unknown parameter a into b, a and b. Next, plus w of 0, w of 0, w plus w. W is nothing but w of 0, w of 1, etc, etc, w of n. So this I can represent this in the form of a equation, that is x is nothing but h theta plus w. Okay, that means theta, why I am taking as h theta, because theta is nothing but a true parameter, a true value of the parameter that has to be estimated. That parameter is nothing but a and b, the unknown parameter. Okay, so that is my h into theta. So theta is nothing but the unknown parameter, that is nothing but a into b. H is nothing but 1 0. In this case, h is nothing but 1 0 1 1 1 2. How it is 1 0? Because the a is constant, that 1, and b, the term corresponding to b is nothing but 0. So 1 0, a 1 1 1 2, like that, and 1 n minus 1. Okay, so I can represent this equation, this model, the previous equation what I had shown you, in this manner. So we can write this equation as x of 0, x of 1, that is n cross 1, 2, etc, etc, x of n minus 1 is nothing but 1 0 n cross 1 matrix, 1 0 1 1 1 2, etc, etc, 1 n minus 1, that is n cross 2 matrix. Just write n cross 2 matrix. Okay, I forgot to write that one, n cross 2 matrix. Other one is a 2 matrix. Next, plus w of 0, w of 1. It is not the matrix term. I couldn't complete that one. That it is been broken. It is not actually. It's not broken. That brackets is being shown in the form of broken type. So it is actually you have to join that bracket. Okay, it is not any special type of matrix or something like that. So it is also n cross 1 matrix only. Okay, so x of 0, x of 1, x of 2, etc, x of n minus 1, that is represented as x of n, and 1 0 1 1 1 2, etc, etc, 1 n minus 1, that is also n cross 2 matrix. That is nothing but represented as the terms of for a and b, and ab is nothing but theta, that is 2 parameter. It is consists of 2 unknown parameter, that is a and b. Next one is nothing but the white Gaussian noise, w of 0, w of 1, etc, etc, w of n minus 1, that is also n cross 1 matrix. Okay, so just represent that n cross 1, n cross 2, 2, and n cross 1 below the matrix sign. Okay, so the above matrix or above matrix equation can be represented in this form as x equal to h, or vector x is nothing but h theta plus w. Okay, and that is nothing but the linear model, and that equation we can call this as a linear model, and h is referred to as observation matrix. Can be represented as x is nothing but h theta plus w, where h, that is the linear model, and we can represent the H as observation matrix. H is called as observation matrix, and W is nothing but the white Gaussian noise with the mean 0 and variance sigma square into it. Okay, H is referred to as observation matrix. Sorry, referred to as observation matrix, and W is nothing but white Gaussian noise with the mean 0 and variance sigma square, right? Okay, sorry. So from the vector form of Sierra-Lee theorem, you have already discussed that in the Sierra-Lee, that is theta vector theta cap is nothing but g of theta, and will be an MVU estimator if dou by dou theta of ln of p of x of theta is nothing but I of theta into g of x minus theta. That already we have discussed in the previous class, that is in the previous video lecture. We have discussed the vector form of a Sierra-Lee theorem, that is theta cap vector theta cap should be equal to g of theta, or theta cap is nothing but g of theta. So how we are getting that one? By using the formula dou by dou theta of ln of p of x is nothing but I of theta into g of x minus theta. Okay, that already we have discussed. Just I am writing that one from the vector form of matrix, from the vector form of Sierra-Lee theorem. I can write dou by dou theta, theta cap is nothing but g of theta will be MVU estimator if dou by dou theta of ln of p of x theta vector x theta is equal to I of theta g of x minus theta. I call this as equation 1 for some g of theta or g of something. I call this as equation 1 for some g of something. Okay, further the covariance matrix for theta cap will be I inverse of theta. That also we have discussed. Furthermore, the covariance matrix for theta matrix for vector theta cap will be I inverse of theta. Okay, in general you can write as I of theta inverse. Okay, and we have p of x of theta is nothing but 1 by 2 pi sigma square raised to n by 2 e raised to minus 1 by 2 sigma square x of h of theta into transpose into x of h of theta. I can represent the p of x of theta in this form as 1 by 2 pi sigma square raised to n by 2 e raised to minus 1 by 2 sigma square x, that is the linear model that I can represent in this and x into h theta transpose into x into h theta. Okay, so 1 minus 1 by 2 sigma square x minus mu the whole square, that I can represent the form of x minus h theta transpose into x of h theta. Okay, so this I will just take the natural logarithm of this one, so I can represent this as ln of p of x of theta is nothing but minus ln of 2 pi sigma square n by 2 minus 1 by 2 sigma square into x of h theta transpose into x of x minus h theta. Okay, so now I will take the differentiation of with respect to theta, the first derivative with respect to theta. The first term will be 0. Dou by dou theta of ln of p of x of theta is nothing but the first term is 0 minus 1 by 2 sigma square dou by dou theta of x of h theta transpose into x of h theta. Okay, so I will take the transpose inside that bracket, that is I can write it as x transpose into theta transpose into h transpose into x minus h theta. So further I can represent this as minus 1 by 2 sigma square dou by dou theta of x transpose minus theta transpose into h transpose x minus h theta. So what I will do, I will just multiply the each and every term here. That is with the first I will multiply with x transpose into x, then theta transpose h transpose with the other term. Okay, so it changes to minus 1 by 2 sigma square dou by dou theta of x transpose into x minus x transpose into x minus x transpose into h into theta minus theta transpose h transpose x plus theta transpose h transpose h theta. I think this is clear for you, is not? So now I can write I can take a theta transpose h transpose x. Okay, we have theta transpose h transpose x, theta transpose x I can that transpose and transpose will cancel. It gives you x transpose h theta. So that I will write instead of theta transpose h transpose x. Okay, in the third term I will represent it. Now I will represent the third term inside the square bracket as x transpose h theta instead of theta transpose h transpose x. Okay, so now my equation will changes to dou by dou theta of ln of p of x theta is nothing but 1 minus 1 by 2 sigma square dou by dou theta x transpose x minus I just clubbing that 2, that is 2 x transpose h plus theta transpose h transpose theta. Since in the previous case you are having the two term, that is x transpose h theta and the theta transpose h x, that theta transpose h transpose x I can now written as x transpose h theta. So x transpose h theta minus x transpose h theta, it becomes 2 x transpose h theta. Okay, I think it's clear for you. Since you are having x transpose h theta or x transpose h can be written as x transpose h, since it is a scalar quantity, x transpose h can be written as x transpose h transpose that whole transpose. X transpose h can be written as x transpose h transpose the whole transpose. Okay, so transpose and transpose will go, it will be only x transpose into h. Okay, and again using the identity, there is one identity is I will just prove this identity in, after completing this equation for the linear model. That is two identities that is one identity is very simple, other identity is also simple only, but I will prove. I have just proved that in this video, coming video we can see that one. So you just take on this identity, that is dou by dou theta of b transpose into theta can be written as b, vector b, and dou by dou theta of theta transpose m theta can be written as 2 m into theta. Theta transpose m theta can be written as 2 m into theta. B transpose theta can be written as b, and theta transpose m theta can be written as 2 into m theta. Okay, so this we can prove it in the coming session. For time being, you just take these two identity. Okay, now what we will get, dou by dou theta of ln of using this identity in the above equation, we can represent this as dou by dou theta of ln of p of x of theta can be written as minus 1 by 2 sigma square. Now we will take the dou by dou theta inside the bracket, so first term is there is no theta term, so it will be 0 minus 2 x transpose h plus 2 h transpose h theta. Okay, since how it comes, because uh, it is by using that identity, that dou by dou theta of theta transpose m theta, that is in the form of 2 m theta. Here m is nothing but, I can represent m is nothing but h transpose into h, or theta transpose m theta. The third term is in the form of dou by dou theta of theta transpose h theta. So theta transpose h is nothing but m. I can call h transpose h is nothing but m. So I can take it as theta transpose m theta. So theta transpose dou by dou theta of theta transpose m theta is nothing but 2 into m theta. So m is nothing but h transpose into h. So I can write as 2 into h transpose h into theta. I think it's clear for you. Okay. And x transpose 2 x transpose h dou by dou theta with respect to it is clear, it's not no mistake now. Minus if I take minus 2 x transpose h, okay, this is clear. Now what happens, I just take 2 outside from this bracket, so 2 and 2 get cancelled. Ultimately it becomes minus 1 by sigma square h transpose x minus h transpose h theta. Okay, minus x transpose h theta. X transpose h is nothing but h transpose h transpose, okay, with respect to theta. So x transpose h, x transpose h whole transpose, x transpose h the whole transpose. Okay, I think just substitute that the 3 identity what I given here in the first equation, then you will get the this equation, that is dou by dou theta of ln of p of x of theta is nothing but minus 1 by 2 sigma square 0 minus 2 x transpose h transpose plus 2 h transpose h theta. So just bring 2 outside the bracket, so 2 and 2 get cancelled, it will be and again minus sign outside, minus 2 outside, so minus and minus it will be plus, so 1 by 2 and 2 get cancelled, 1 by sigma square h transpose x, if you bringing transpose inside the bracket, it will be h transpose into x minus h transpose h theta. Okay, it is clear. So I will just assume h transpose h is a invertible matrix. So invertible, so we can write, assume h transpose into h is invertible. H transpose h is invertible, so we can write dou by dou theta of ln of p of x of theta. I will take h transpose h outside the bracket. Okay, h transpose h outside the bracket, so it will be I am just assuming that h transpose h is invertible, so we can write dou by dou theta of ln of p of x of theta is nothing but 1 by h transpose h, I will take outside, 1 by sigma square, so it will be h transpose h inverse h transpose x minus theta. I think it's clear, it's not h transpose h inverse, that 2 get cancelled, so you will have only h transpose x minus h transpose h into theta. Okay, it's clear. So this equation is exactly of the equation that we have discussed in the equation 1 that I had in the previous slide. I have indicated the equation 1, that is from the vector form of general CRLB. I can represent that dou by dou theta of ln of p of x of theta is nothing but I of theta g of x minus theta. So if you are comparing that equation 1 with this equation, it is somewhat similar, where I of theta is nothing but h transpose h by sigma square, g of x is nothing but I of h transpose h inverse h transpose x, and theta is nothing but theta itself. Okay, so that if you are comparing these two, I can represent it, that is this is exactly of the form of equation 1. So I can write g of x is nothing but theta vector theta cap. So with the g of x is nothing but vector theta cap, that is nothing but h transpose h inverse h transpose x, that is this calls as equation 2, and I of theta, that is official information, h transpose h by sigma square, and I of theta is nothing but h transpose h divided by sigma square. Hence the MVU estimator for the theta is given by the equation 2, and its covariance can be written as, hence the minimum variance unbiased estimator for theta is given by the equation 2, and its covariance matrix is given by covariance of theta cap, vector theta cap, that take it as capital C, covariance of vector theta cap is nothing but I inverse of theta. I inverse of theta will be sigma square h transpose h inverse. Okay, covariance of theta cap, it is not C, it is capital C, that means that C indicate the covariance. Okay, covariance of vector theta cap is nothing but I inverse of theta, which is nothing but sigma square h transpose h inverse. Okay, so the MV estimator for the linear model is efficient in that it attains the CRLB. The MV estimate for the linear model is efficient in that it attains the CRLB. I think this is clear for you how we are taking the MV estimator using the linear model. So if they are giving what you call as more parameter, in this case we are taken only the two parameters as A and B. Okay, if they are giving the observation x of 0, x of 1, etc., x of n minus 1, that's better to go for the linear model only. It is very difficult to solve it by using extension of vector parameter using CRLB theorem and all other method, but better to go for the linear model if they are giving, if the values of n is more than 2 or more than 1. Okay. So the two identity what I have shown there, we can just I told you I will explain this one. We can just explain that one. The first identity you just do it by yourself. I will just give you only the points only. It is very simple. That's dou by dou theta p of b transpose in theta is nothing but b. Anyway, dou by dou theta is nothing but dou by dou theta 1, dou by dou theta 2, etc., dou by dou theta 3. If I take in three condition, dou by dou theta 1, dou by dou theta 2. If it is 3, if theta I, if I taken I as 3, I can write it as dou by dou theta 1, sorry, dou by dou theta 1, dou by dou theta 2, dou by dou theta 3, and b I can write as b1, b2, b3, and theta b transpose is nothing but b transpose theta is nothing but b1 theta 1 plus b2 theta 2 plus bt3 theta 3. Just do this one. Okay, it is very simple. You can able to solve this one. Okay. So the second case I will just with dou by dou theta transpose m theta is equal to 2 in temperature. Just we can prove this one, how we are getting. So I can write it theta as theta 1, theta 2, theta 3. I will take I is equal to 3 only. So theta I can vector theta I can represent in the form of theta 1, theta 2, theta 3. Capital M I can represent in the form of m11, m12, m13, m21, m22, m23, m31, m32, m33. Okay, that is theta is nothing but theta 1. It is a column vector, theta 1, theta 2, theta 3. M I can write m11, m12, m13, m21, m22, m23, m31, m32, m33, and now I have to go for m into theta. So ultimately what you will do, you will multiply with the theta 1 with respect to theta with respect to m. So m into theta I can represent it as m11 theta 1 plus m12 theta 2 plus m13 theta 3. Oh, sorry, I made one mistake here. M31 theta 1 plus m32 theta 3 2 plus m33. Sorry students, one mistake what I have made is I have written m11 plus theta 1. It is not like that. M11 theta 1 plus m12, just this matrix what I have indicated here, that's m theta, is wrong. Just take down this one. It is in the form of m matrix m11, that is the first row. I am telling about the first row. Okay, first row is nothing but it is first first row. Okay, first row is nothing but m11 theta 1 plus m12 theta 2 plus m13 theta 3. The second row is nothing but m21 theta 1 plus m22 theta 2 plus m23 theta 3. And third row is m31 theta 1 plus m32 theta 2 plus m33 theta 3. Okay, so the matrix what I have shown here, that is m into theta, is wrong. Just change this matrix what I have indicated here. It is actually this. If you are multiplying with m and theta, you just do that one by yourself. You can able to see the thing what I have indicated here is wrong. Just is incorrect. Just make a small change here. It is exactly in the form of m11 theta 1 plus m12 theta 2 plus m13 theta 3. The second row is m21 theta 1 plus m22 theta 2 plus m23 theta 3. And third row is m31 theta 1, m32 theta 2 plus m33 theta 3. m11 theta 1, first row is m11 plus, here I have written m11 plus theta 1. It is not like that. m11 into theta 1 plus m12 into theta 2 plus m13 into theta 3. The second row will be m21 into theta 1 plus m22 into theta 2 plus m23 into theta 3. The third row is m31 into theta 1 plus m32 into theta 2 plus m33 into theta 3. It is clear for you people. Okay. Now I can represent as theta transpose m theta in the form of theta 1, theta 2, theta 3. The taking the transpose, and m theta is nothing but m11. That also I have made mistake. M21 theta 1 plus m22 theta 2 plus. Okay, so here also that that matrix what I have indicated is wrong, so just change. I think in the next section I have made correct. We can see that one. Okay, here also just m theta is nothing but the m11 into theta 1 plus m12 into theta 2 plus m13 into theta 3, m21 into theta 1 plus m22 into theta 2 plus m23 into theta 3, second row. Third row is m31 into theta 1 plus m32 into theta 2 plus m33 into theta 3. Just change this matrix also. Okay, a small mistake here in the two equation, so that will be changes to normally m11 theta 1 square plus m12 theta 1 theta 2 plus m13 theta 1 theta 3 plus, I think this will be correct, m21 theta 2 theta 1 plus m22 theta 2 square plus m23 theta 2 theta 3 plus m31 theta 3 theta 1 m32 theta 3 theta 2 plus m33 theta 3 square. This is correct. Okay, only thing is the two matrix, a small mistake. Instead of plus, it should be multiplied, and it should be on with the 3 columns 3 rows. Okay, here I have written 3 column 3 rows. It is wrong. You having only 1 column and 3 rows in the two matrix. Okay, so that two small change, that just change that one. Okay, so this we will get. So now what we'll do, we'll take the dou by dou theta 1 of theta transpose m theta 1 m theta. Similarly, dou by dou theta 2 of theta transpose m theta, dou by dou theta 3 of theta transpose m theta. So first we will take dou by dou theta 1 of theta transpose m theta. dou by dou theta 1 of theta transpose m theta. That is nothing but, with respect to theta, it is 2 m11 theta 1, m12 theta 2 plus m13 theta 3. With respect to theta 1 we have to do differentiate, plus m21 theta 2 plus m31 theta 3. Now with respect to theta 2, that is dou by dou theta 2 of theta transpose m theta. With respect to theta 2, the whole equation with respect to theta 2 we have to differentiate. So that is m12 theta 1 plus m21 theta 1, I have already written m21 theta 1 plus 2 m22 theta 2 plus m23 theta 3 plus m32 theta 3. Now with respect to theta 3 we have to differentiate dou by dou theta 3 of theta transpose m theta. Sorry. m13 theta 1 m23 theta 2 plus m31 theta 1 plus m32 theta 2 plus 2 m33 theta 3. So what I can do, so if m is symmetric I can represent it, if m is symmetric I can represent all these things, that is if m is symmetric I can represent dou by dou theta 1 theta transpose m theta 1 can be represented as m that is what you call as here, what all things are there, m12 m11 m12 m12 or m21 and m13 and m31. So if I am taking this m2, you just listen here, if m is symmetric I can represent as m12 is similar to that of m21 and m13 is similar to that of m31. So I can represent the first equation, I can represent 2 m11 theta 1 plus m12 m12 theta 2 plus 2 m13 theta 3. Okay, the first case dou by dou theta 1 of theta transpose m theta. So I will take in the 2 outside the bracket, so 2 into m11 theta 1 plus m12 theta 2 plus m13 theta 3. Similarly, dou by dou theta 2 of theta transpose m theta will be 2 into m21 theta 1 plus m22 theta 2 plus m23 theta 3. And the third case, dou by dou theta 3 of theta transpose m theta is nothing but 2 into m31 theta 1 plus m32 theta 2 plus m33 theta 3. So now if you are taking this in the form matrix form, that is dou by dou theta of theta transpose m theta can be represented in some matrix, that is dou by dou theta 1 of theta transpose m theta, dou by dou theta 2 of theta transpose m theta, dou by dou theta of theta transpose m theta can be represented in the form of matrix. Okay, that is dou by dou theta of theta transpose m theta can be written as matrix in form, that is okay, dou by dou theta 1 of theta transpose m theta, dou by dou theta of theta transpose m theta, and dou by dou theta of theta transpose m theta. That is nothing but can be represented as all the matrix values, that is 2 into m11 theta 1 plus m12 theta 2 plus m13 theta 3. Next row will be 2 into m21 theta 1 plus m22 theta 2 plus m23 theta 3, and the third row will be 2 into m31 theta 1 plus m32 theta 2 plus m33 theta 3. Here also one mistake I have done, I forgot to change that one in the second case. Okay, so a small mistake here also, that is matrix should be 2 into m11 theta 1 plus m12 theta 2 plus m13 theta 3. Then the second term will be 2 into m21 theta 1. It is in the second row I have written as m11, instead of m11 it should be m21, instead of m12 it should be m22 instead of m13, it should be m23. I think it's now it is clear. Okay, small change in the middle term. Okay, that is the second row. You just change that one. Okay, there is also one small mistake is there. Okay, so that changes to 2 into, if I take 2 outside, m11 theta 1 plus m12 theta 2 plus m13 theta 3, and second term will be m21 theta 1 plus m22 theta 2 plus m23 theta. That also I have written the mistake, so just change. It should be m21 theta 1 m22 theta 2 plus m23 theta 3. The third should be m31 theta 1 plus m32 theta 3 2 plus m33 theta 3. So it is just of the form of 2 into m into theta, 2 into m into theta, hence proved. Okay, slight mistake is the that you just change it. Okay, just I have copied the first equation directly second, but I have forgot to change that base. Okay, subscript, that is why. Okay, I think it's clear. I have cleared the mistake also, so don't write directly here. Two mistake is in that matrix. Here 2 in the 2 matrix, 2 second row is you have to change the second row because there is a mistake in the second row. It should be m22 theta 1, sorry, m21 theta 1, m22 theta 2, m23 theta 3 in both the matrix. Okay, similarly in the previous case also. So this is the thing, how we are getting the two identity. So one identity is very simple, just prove by yourself. Okay, so this is something regarding the linear model. Now just we can see one example, a small example for linear model. It's very small example. Okay, I'll give you that observation. That is in a certain experiment, the voltage measurement appears to have quadratic relationship with the same instance t0, t1, etc. t n minus 1, the same in time instance t0, t1, etc. t n minus 1, with the deviation being attributed to experimental error or noise. Okay, one more, error or noise. Anyway, error is nothing but noise only. Okay, attributed to experimental error or noise. So you can represent this in the form of a reasonable model for the data observation, can be written as in the form of x of tn. A reasonable model for the data observation is x of tn can be written as theta 1 plus theta 2 tn plus theta 3 tn square plus etc. Sorry, plus if I take in 3 terms, it will be n equal to 3. I can take it as wtn, n equal to 0, 1, etc. n minus 1, where w of tn is nothing but a white coarse noise. Okay, so this I can write it as w x of t0, x of t0, x of t0 can be written as theta 1 plus theta 2 t0 plus theta t t0 square plus w of t0. Similarly, x of t1, theta 1 plus theta 2 t1 plus theta 3 t1 square plus w of t1. Now etc. I can represent as x of tn minus 1 can be x of tn minus 1 can be written as theta 1 plus theta 2 tn minus 1 plus theta 3 tn minus 1 square plus w of tn minus 1. So it is similar to that of what we had just discussed in case of linear model. So put that in terms of an equation, that is x equal to h into theta in the form of matrix, that is x of t0, x of t1, x of tn minus 1 equal to 1, second term will be t naught. In the previous case what I have written, 1 0 1, you just see that linear model, okay, 1 2 1 0 1 1 1 2 etc, etc, 1 of n minus 1, like that. So here it will be x of t0, t0, x of t1, x of tn minus 1, 1 t0 t naught square, t1 1 t1 t1 square, etc, etc, 1 tn minus 1 tn minus 1 square, plus w of 0 theta 1 theta 2 theta 3 etc, theta n minus 1. That is the unknown parameter that has to be estimated. This equation can be put in the matrix form as x of t1, so t naught, x of t1, x of etc, etc, x of tn minus 1, that is n cross 1 matrix, can be written as x1 t naught square, 1 t1 t1 square, etc, etc, 1 tn minus 1 square, tn minus 1 t1 square, etc, etc, tn minus 1 square. So slight change in the matrix, writing the matrix. So theta 1 theta 2 theta 3, this is a unknown parameter, that is a 3 cross 1 matrix. First one is nothing but n cross 1 matrix, second one is nothing but n cross 3 matrix, the third matrix is nothing but 3 cross 1, the last matrix is nothing but n cross 1. I think it's clear. It is of the form of linear model. It is of the form linear model, that is x is nothing but h theta plus w. Okay, x is x theta, x is nothing but x is nothing but h theta plus w. N cross 1, next is n cross 3, 3 cross 1, n cross 1. Okay, so this can be represented in the form of x is nothing but h theta plus w. So in general, the experimental data may be varies as polynomial of order p minus 1. In general, the experimental data may varies as polynomial of order p minus 1, where I can write x of tn is nothing but theta 1 plus theta 2 tn plus theta 3 tn square plus etc, etc, theta p tn p1 tn raised to p minus 1, theta 1 plus theta 2 tn plus theta 3 tn square plus etc, etc, theta p tn p minus 1. Okay, so the vector theta has p components here. Okay, vector theta has p components, and I can represent the h, the terms h, and h can be represented as 1 t naught square, etc, etc, t naught raised to p minus 1. Next 1 t1 square, etc, etc, 1 t1 square, etc, etc, t1 raised to p minus 1. The last one is 1 tn minus 1 tn minus 1 square, tn minus 1 p minus 1. That is n cross p matrix. This is okay. So this observation matrix sorry, has a special form of this matrix can be represented as Vandermonde matrix. So this expression is nothing but Vandermonde matrix, Vandermonde matrix. Okay, and the MV estimator is nothing but theta cap, vector theta cap is nothing but H transpose, that you know, H transpose H, the whole inverse, H transpose X, H transpose X sorry H transpose H inverse H transpose X. So the resultant wave fitting is I can represent that as wave fitting in the form of, similarly, that is the theta 1 as S of t, and over theta 1 plus theta 1 is theta 2 t plus etc theta p t raised to p minus 1. Okay, in general I can write as wave fitting. Okay, I think this is clear for you. It is only general example, no need to solve this one. It's only general example. If you are giving some certain, here I have taken n minus 1. If you are giving some 3 minus 1 something like that, 2 or 4 minus 1 or something like that, n equal to 4, then it will be 4 minus 1, that is 3 terms. Next we can we can have one example of linear model that is called as Fourier analysis in the next video. Thank you.